Welcome to Circuit 4C, where we'll be closing out Project 4 by building a homemade Who Am I game. In this circuit, we'll be using the buzzer and push button that we're already familiar with, but we will be adding one new component, the battery pack. For this circuit, we want to be able to ditch our USB-C cable so our game can be played on the go. So we'll have to set up our battery pack. Track down 4 AA batteries and insert them into the battery pack. Batteries are polarized, so make sure you follow the diagrams on the battery packs themselves that show you what orientation to put them in. Cut a small piece of the dual lock that came with your kit and attach one side to the bottom of your assembly's base plate and the other side to the battery pack. If you'd like to, you can also use some dual lock or some other tape to secure the OLED screen to your base plate, which will make it easier to play the game. When connecting components with the dual lock, make sure to not use too much, as we'll need some in Project 5. Now, when we want to disconnect our board from our computer, we can connect the battery pack to the barrel connector on our IoT Red board and power it that way. This still leaves one problem though. To drive our circuits, we've been running our code from our Jupyter Notebook cells via the USB connection to our computer. So how can we make our code run without it? Jupyter Notebooks do not have a built-in way to save code to our boards so that it runs automatically at startup. However, MicroPython itself does. On MicroPython boards, if you have a file called main.py on your board, it will run automatically every time your board is powered on. To help you write code from a Jupyter Notebook cell to this main.py file on your board, we've added a magic command, which is the word save with % on either side. If this special text appears in your code cell, the content below it in the cell will be saved to the main.py on your board. When adding this magic save command, make sure to add it in a comment, as it is not an actual line of MicroPython code and it will error if it runs as a normal command rather than a comment. So for this project, we've put all of our code into a single cell with the magic save command at the top. When we run the cell, the code will all be saved to our board, and then we can disconnect our USB-C cable, connect our battery pack, and the game will begin. Note if you are instead running your code from Thonny, you don't have to worry about this. Just click the green run button as usual, and we've added the necessary code to the built-in example to copy it to main.py when it is run. That's about it for theory for Circuit 4C. Now let's build the thing. For this circuit, we will keep our OLED connected by the quick connect cable, and then add back in the push button and the buzzer, each with their signal wire and ground wire. Remember that we'll leave the battery pack disconnected at first when we run the code cell to save our code to the board. And then we'll disconnect the USB-C cable and connect the battery pack to the IoT Red board's barrel connector. This circuit has a lot of code, and it's all in one code block, which can be quite overwhelming. Remember that you don't have to 100% understand every single line, and you can explore it as much or as little as you want. We'll run the single big cell, wait for it to finish, and then disconnect our USB-C cable. Now we'll connect the battery pack and our game begins. If you've ever played a game like HeadsUp, Hedbanz, or Guess Who, this is a similar Who Am I game. Hold the game up to your forehead and different animals will be displayed on the screen. The other players in the game, like your friends and family, will be able to see the screen and will give you hints on what your animal is. If you guess the animal correctly before the time runs out, click the button and you'll move on to the next animal. Your score is based on how many you correctly guess in time. Feel free to change the words list and get creative customizing the words and category. That's all for Project 4. You've mastered your OLED display and have already used it in some pretty fun circuits. Only one more project left to go, so stick around for Project 5, where you will build your first robot.